Greetings. I'm Yvonne Stapp for Science for the Public, and I welcome you to Contemporary Science Issues and Innovations. Today, we're going to hear about the importance of microbes called algae in oceans, bays, other kinds of waters, and how toxic runoff from farms and industries impact these vital organisms. Our guest, Patricia Glibert, is a professor at the University of Maryland Center for Environmental Science. She's a phytoplankton ecologist whose research focus is how fertilizers and other nutrient loads of all sorts cause harmful algal blooms in natural waters. She'll also explain the potentially harmful effects of something called marine geoengineering, which is a concern for a great number of marine scientists. Dr. Glibert, welcome and thank you very much for joining us today.
My pleasure.
And if I could start out, please explain what algae are and their role in the general ecosystem of the waters, I guess.
Algae are the production powerhouses of aquatic systems. They are the food that is the basis of all life in aquatic systems, whether it's freshwater or marine. They feed the fish, they feed the ecosystem, and without them, we wouldn't have any aquatic life.
That's kind of important. Yes, okay. Thank you very much for that. And these are microorganisms then, right? And they're vitally important. Thank you. And I thought that there were algae blooms anyway, but are all algae blooms, I guess you say algal blooms, are they all bad or are some okay? What's the situation?
So first we have to understand that every drop of water, whether it's freshwater or marine, contains thousands of these microscopic algae, single-celled organisms, along with millions of bacteria and viruses. This is the natural ecosystem. However, there are times when the ecosystem can lead to algal blooms, which is an increase in biomass above background levels. Some of these algal blooms are natural and part of the ecosystem, which again feed the food web. But there are other algae that can be harmful, and these are the ones that may have toxins that can contaminate seafood, that can cause fish or shellfish kills, human health impacts, and can alter ecosystems in negative ways.
Right, I see. So these are these the ones that you call HABs or harmful algae blooms?
Right. We use the term HAB as an all-encompassing term.
Okay.
It's not a specific species. It's the general phenomenon of these blooms when they cause negative impacts, regardless of what those negative impacts are.
I see. And one of the things that has been in the media that draws attention for the general public is something called a red tide, and that has to do with these toxic ones, I guess. Could you explain what that is and the effects?
Red tide is another term for many of these harmful algal blooms. It's an older term because it's used because when certain types of algae bloom, they literally color the water red, and it's due to the same pigments in their cells as the same pigments in the leaves that turn vibrant colors in the fall, the same type of pigments, so the water turns red. Now, it's still a local term used in many situations, but it's not a universal term because not all harmful algae are red. Some can be green, some can be brown, some don't even show up as a color because they can be harmful in the ecosystem, even at very low levels that we wouldn't see to the human eye.
I see. And now, what causes these, go back for a bit there, these runoff problems. Could you give us some background on that? What's in that runoff? Where does it come from, and so on?
So one of the reasons that we have an algal bloom, there are natural reasons, for example, natural seasonal cycles. But one of the problems is we're seeing more algal blooms and more harmful algal blooms as a result of the process of eutrophication, which is the enrichment of water with nutrients, primarily nitrogen and phosphorus. Now we have, in the last 5-6 decades, created a very large nitrogen footprint on the globe. We're all familiar with our carbon footprint, but we also have a huge nitrogen footprint, which comes from population, increasing numbers of people, and the sewage that is produced by people. We don't have adequate sanitation in many parts of the world. We also are using fertilizers in farm applications and lawn applications, golf course applications at very high levels. And these nutrients are put on the fields to grow crops. So when these nutrients run off into the waters, they perform the very same function. That is, they enrich the microscopic plants in the water, and they grow to very high levels. And so when this happens, there are several effects that can happen. One is that just by virtue of this high biomass, and then it begins to die and decay, oxygen is used up and we create dead zones. The other problem is that we shift the biodiversity of the community at the microscopic level and then at the higher food level. So we have many changes that can occur when we have nutrient over-enrichment.
Yeah, that's pretty serious. So it's been the type of nutrients that are being produced, and I guess the quantity. And we usually think of this as into oceans and maybe bays, I guess like salt water, but is it everything, fresh water and salt water?
Freshwaters also have a huge harmful algal bloom problem. Different species, of course, and these species create different types of problems. More green-colored algae in freshwaters. These are caused by actually blue-green algae, which are more bacteria-like than plant-like. But their toxins are of major concern, not only due to just the sheer accumulation, looking sometimes like green paint spilled on the waterway, but those toxins can get into drinking water supplies and can cause human health impacts when they get into drinking water supplies.
Wow. So it really is much broader. The importance of these things is much broader than we might be inclined to think. Just as an aside, Dr. Glibert, there's been an announcement just recently that just a huge percentage of freshwater fish are now threatened by extinction. Does this have any relationship to it, the toxins like this, by any chance?
There are many causes for these extinctions. Algal blooms can contribute in some cases. The freshwater blooms, returning to their effects in freshwater, one of the major concerns of long-term exposure, people who routinely are exposed to freshwater blooms over many years, linking liver cancer and liver failure to these toxins.
Wow, I see. So it affects the life in the waters, but also directly human life, and that we hear very, very little about. So thank you for that. And
yes, for example, the city of Toledo, the whole water system was shut off a number of years ago when these toxins were found.
Wow. So the water purification system is not adequate? Is that it to get rid of these toxins?
Depends on the water purification system within different
Sure,
systems.
sure.
And some are able to remove the toxins, but others do not. And some monitor for these toxins and others do not.
Okay, so now we know that these blooms, the toxic ones, can affect waters, fresh water and salt water, and that it is very dangerous for the sea ecosystems or the marine ecosystems and for things like fish, but also human health. So is there any geographic area in the world that is particularly affected, or is it just about everybody?
We are seeing blooms increasing around the world. Now, there are many regional differences, of course.
Right.
We have seen massive increases in blooms in waters where human population is growing. China, that has developed significantly over the past several decades, now has a massive harmful algal bloom problem.
Oh,
But we see harmful algal bloom problems in all waters of the US, all waters of Europe. We have to understand, of course, that our global database is imperfect, so there are parts of the
right,
world
sure.
that we don't have good data for. We know blooms have occurred in the Mideast,
Yeah.
in the Arctic.
Wow.
They are occurring virtually everywhere, but different blooms occur in different species of blooms occur in different parts of the world caused by different effects.
Thank you. As scientists in your field, when they look at this, do they have any recommendations? Are they sending out warnings that something's got to be done, or is it not critical at this time? Do you see what I mean?
Yes, one of the major fields and one of the fields where advances are happening very rapidly is our ability to monitor these waters and then to develop predictive models. Just like weather reports, we want to have reports of the health of the oceans so we can protect beachgoers, but also fishermen. And we want to protect human health because many of these toxins accumulate in shellfish or fish. And so we don't want those products to get to the market if they're contaminated with these toxins.
Yeah,
Some of these toxins can cause enormous human health problems, such as in the case of the New England species, paralytic shellfish toxin, that can lead to respiratory paralysis.
Oh my goodness.
A large enough dose of that, and one isn't breathing for very long, and death can follow. Another effect can be short-term memory loss. Another effect can be just routine upset stomach and diarrhea. So there are many effects of these toxins. And so monitoring our waters, monitoring our products that we consume become a very important part of what we do, and finding new tools to do that and to improve our predictive models
Yeah.
is really where our advancements are going very quickly.
Yeah, that's great. What seems to be missing is the warning to the public. So do you see what I mean? I mean, are you aware of this? Like when you go to the food shopping, do they put notices on the lobsters or the shellfish or anything that this might be dangerous?
There are many warnings for the public. What gets into the food store, for example, are products that are safe.
Oh, okay.
So the warnings, notices would be posted at beaches. Please don't go down and collect mussels yourself. There are many notices and many outlets to get the word out to the public. But at least in the US and in
Yeah.
many parts of the world, we can be sure that when we buy products at the store, we're buying a safe product.
Okay, that's helpful. And
The
then,
warnings go out also to shell fishermen and fishermen
yeah,
to prevent them from harvesting
yes, yes, I understand.
at the wrong time.
Right. But lots of people go out fishing, though, by themselves and or collecting shellfish around the world. And there are areas of the world where people are really quite dependent on seafood, right? Or, whether it's fresh water or ocean food. And so they seem like they might be quite vulnerable. People might be vulnerable. Do you think that's the case?
There are parts of the world where people routinely do get sick from these events. And this has happened throughout history.
Yeah.
We know many historical events of people getting sick from collecting shellfish on their own. And we have to be aware that aquaculture is growing very rapidly
right.
in many parts of the world. And aquaculturists are very attuned to these events and certainly don't want to be putting products on the market that cause people to be sick.
Right, okay, understand. And just as another aside, I see you work a lot on the Chesapeake Bay. The dead zone situations there and so on. And there's a report out on 2023 was one of the best or the best report on dead zones that's the smallest dead zone on record. And I think that was almost 40 years, I'm not sure, of monitoring. What would you attribute that to, that it has declined when it seems to be, I think of it as increasing everywhere?
Well, the Chesapeake has been certainly very much working hard to reduce nutrient inputs. And this has been a multi-decadal effort to reduce nutrients, and nutrients have gone down in terms of pollution in the Chesapeake Bay. On the other hand, we have to be aware of changes in climate, and precipitation plays a major role in bringing those nutrients into the bay. So nutrients that we apply on land, when precipitation hits the land, those waters eventually make their way into streams and rivers and into the bay. And when we have a dry year, we have less runoff. But with climate, we have to be aware that we are changing precipitation patterns.
Yeah.
We're changing the seasonality of precipitation. And with warmer weather, precipitation, when it does occur, now often is wetter. That is, we get more intense rains because warmer atmosphere holds more moisture. So when it does rain, there's more intense rain, and those intense events are what can cause massive influx of nutrients into our waters.
That seems very important then, because of in other words, in areas that are getting floods, getting massive rains. We've just had this experience in a couple parts of the country, including yours, I think. You got some rain this week, or snow, or something like that, in Maryland. Then in this situation, you need to have the sources of this pollution, of these, you call them nutrients, that create this problem. Do the sources, are they paying attention to this, like agriculture and so on, sewage monitoring and so on? Are they taking care of their end of this to try to prevent the problem?
There are major efforts to do so.
Okay.
Major efforts to do so. And we've seen upgrades to sewage treatment plants around the Chesapeake Bay. And our farmers really do pay attention to the amount of fertilizer they're using. They're using best management practices, buffer strips. They don't want to use more nutrient than necessary because it's an expensive investment for them, and so they want to do the best effort that they can as well. But nevertheless, we need nutrients on our farm fields to grow our food. And we're also growing many of our animals in concentrated animal operations,
yes.
which are huge sources of nutrients as well.
That's a really good point. Thanks for that, because that it's hard, I guess, to control that. Just, you mentioned buffers, that these, like the agricultural sources, the feed into both freshwater and saltwater, I suppose, where depending on where they are. Could you just tell us quickly what these buffers are?
Buffers are just a vegetation around a waterway. So rather than planting right up to the edge of the waterway, natural vegetation is left within X number of feet of the waterway as a natural way to absorb those nutrients.
Okay, thanks for that. There's one other thing, is that there is an interest, given climate change now, in something called geoengineering. So we have solar geoengineering, and we have marine geoengineering. And there is quite a push for increasing, via geoengineering techniques, to increase the absorption of CO2 by the oceans, which contribute a great deal to this absorption process anyway. And I believe that you are among a number of scientists concerned about this. Can you explain what they use in marine geoengineering and what the concerns are?
So the concept with marine geoengineering that you were explaining, to use the oceans as a way to absorb CO2, to take out this excess CO2 from the atmosphere. The process to do that is the production by algae and their photosynthesis. They absorb the CO2 in the process of photosynthesis. So in essence, what the idea is to create algal blooms that would take out more CO2 from the atmosphere, and then they would settle to the bottom and keep that CO2 locked in the ocean for decades to come. Now, we know what happens in algal blooms. In order to make an algal bloom, we have to fertilize in some way. So there are a number of ways we can fertilize, and different parts of the oceans need iron to make an algal bloom. So there have been efforts to do iron enrichment experiments in parts of the world to create an algal bloom. In other parts of the world, other nutrients are proposed to create these algal blooms. We have to be mindful that what we are doing, in essence, is eutrophying those waters. So we have the potential to promote the growth of harmful algal species. And this has been observed in some of the iron enrichment experiments, that the species that preferentially grew were species that were toxic. We also have to be aware that depending on where we do these enrichment experiments, we have the potential through the death of these organisms and then their decomposition to create more dead zones. So on the one hand, the oceans present a great opportunity to absorb the CO2, but we have to be careful how we propose to do it, and we don't create other problems while solving one.
Right. And I hope that the your scientific community, the scientists in your field, will get more information out there, because that is the whole business of the geoengineering, the different types, has caused alarm among scientists, and yet there's quite a push because you have to get rid of this CO2 in the atmosphere, and so it looks, in a lot of media presentations of this information, it looks like an easy way to take care of things, and we need your cautionary statements on this for sure, and appreciate your expertise on that. So I hope you will, to continue to comment on that. And I think, is there anything else that you would like to add about the business of these algae blooms, and before we have to leave?
Well, we have to recognize that these algal blooms are, on the one hand, a natural phenomenon,
Right.
but on the other hand, they pose significant problems, not only to our ecosystems, but to human health. And while we're doing our best to get the word out to the public should be aware that these are real events when they occur. And if there are public warnings, pay attention.
Yeah.
Pay attention to the public warnings, because they're there to protect your health and your water supply.
Yeah.
And we know that to solve these problems, the answers are very difficult. We have to reduce nutrient pollution ultimately, but it's going to take a long, long time to return our systems back to their natural system, their pre-eutrophication
Right.
condition.
Right. That's a major point right there. It's going to take a long while, and it's a very complex thing with the growing global population, I guess, and what that causes for these for the marine ecosystems generally with these runoffs. Dr. Glibert, this was wonderful information. I really appreciate your sharing your expertise today. Thank you so much, and good luck with all your research.
Thank you.